All right, here's another linear regression problem that we're going to do on Desmos. If you watch the whole video for number one, this is a great one to maybe pause what I'm doing and see if you can get a step or two ahead of me. Here we don't have a scatter plot. All we're doing is putting this data into Desmos and then running the linear regression and interpreting it. So the first thing I'm going to do is I'm going to pull up Desmos and I'm going to see if I can get this data put in. I need to clear out. You want a clean screen anytime you're starting a new problem. On the OST, that'll happen for you automatically, but I think it's really helpful if you do that every time when you're working on Desmos on one of our tests especially. So when we're working on statistics and only statistics, we're adding a table. And I'm going to put my data in. So 7 goes with 15, 16 goes with 17, and if you've already done this, you can fast forward. 18 goes with 14. Year 22, we have 31 cards missing. And year 27, we have 9 cards missing. So we have baseball cards and years. If you want to see this, you can zoom out. It's not a very good line. I know we didn't even look at our scatter plot on number one, but you definitely could have zoomed out like we did here. Now we want that linear regression. So I'm going to show you the buttons to push in case you're doing this on an iPad. You want Y1. And then instead of equals, you use this guy down here under B, tilde. MX1 plus B. You're telling it to look at that table that you have X1 and Y1 in. That's why you can't just type Y equals MX plus B. You have to tell it, hey, look at that table. Okay. So there's our line of best fit over there. Our slope is 0.027. Yuck, kind of gross. 0.027x plus our y-intercept is 16.71. Interpret the slope in context. Okay, again, the slope is y over x, so let's make that a ratio. 0.027 cards missing per year. So we lost 0.02 cards per year. Interpret the y-intercept. To start, he was missing 16.71 cards. So if you're thinking to yourself, like, those are really weird numbers for this problem, you're absolutely right. And here's how we're going to deal with that. If we look at our R value here, our R value is 0.024. 0.024. That is almost zero. There is almost no correlation here between years and cards missing. So this is not a good model. Not a good model at all. This means that there is a weak, and it is positive, weak positive relationship between the age of a set of cards and the number of missing cards. So here, this graph, if you click back over to it and you zoomed out, if you look at that line that we built that's in red and you look at that scatter plot, that doesn't match at all. So this is not a good problem to use linear regression on. But sometimes you don't know whether your model is going to be good or not until you run that regression. If you were trying to build a model for this data set, then you would try something else. And you'll learn about other models a little bit later in the school year. All right, I'm going to do a video for the multiple choice problems at the end of the review, so you can click over to that video if you need to see